Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now for Course 2 Honors for Tuesday, April 7th, 2020. We are ramping up for our mini assessment this week on trigonometry. So today in the lesson notes, you're going to see a couple things. I'm going to show you the reference sheet that I will allow you to use with formulas. I would have given you this reference sheet if we had taken the test in school, just because I don't really see the value to memorizing the laws. So if you want to, feel free to pull that up, and you can totally use it to help you with this Do Now. Also, just going to throw out a quick reminder. Please make sure you've done the Course 2 Honors test assignment, as well as the trig review assignment. And if you turn it in and it doesn't work at first, it looks like you didn't turn it in, that's because there is that last question that you have to type in work by hand, and I need to manually grade that before it releases the score. So don't worry about that. In terms of today's Do Now, again, we're thinking about wrapping up some concepts here. So what I want you to do is, you have two sets of information. First, can we find the length of little b if little a is 15, little c is 9, and big B is 67 degrees? And then, can we find the measure of big F if little f is 9, little g is 10, and big G is 70 degrees? What you need to do is think about the information you're given, think about what you need to find, maybe take a look at the formulas if you needed, and then what I want you to do, after you've had a second to do that, pause the video. Okay, maybe pause the video first, but in any case, pause the video, try to get me the answers to these two, and then when you're ready, unpause, and I'll show you how to solve them. All right. So here we go. In the first one, so basically our only choices are either the law of sines or the law of cosines. And so essentially, you need to figure out which one you're going to use. And for the first one, what you want to use is you want to use the law of cosines. And the reason you want to do that is because I'm asking you to find a side, okay? But what I'm giving you is two of the other sides, because we're assuming, right, this is trigonometry, we have a triangle, and the opposite angle. So if you don't know how to do it just by the given information, okay, we'll set up a triangle. I'll try that again because I want to make sure my triangle looks nice. Okay, and so I've got little a is 15, little c is 9. Okay, so you can imagine this being C, this being B, this being A. Actually, I think we need to reverse that a little bit. This needs to be B, and this needs to be, okay, and then this here needs to be 67 degrees. So this is a situation where you do want to use the law of cosines. Because these are different, right? So it's not a 90-degree triangle. We can't figure out any of the other angles or sides. The Pythagorean theorem doesn't work because, again, it's not a right triangle. So, and the other thing is, because these sides are not congruent, we actually are not able to figure out anything about the base angles. If they were the same length, we could conclude this was an isosceles triangle, which would mean that we could then use the fact that the angles add up to 180 and the fact that these are the same to figure out what they are. But again, in this case, because we don't have A or C, the law of sines does not work because you need to have at least two angles, right? And I'd have to have an angle, either this angle across from 9 or this angle across from 15. But notice I do have these other two pieces of information. So what I know is that b squared, okay, equals a squared, so 15 squared, plus c squared, right, minus 2bc cos 67. Okay, and so what I'll do is I'll jump on my calc and I'll figure that out. So I've got 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine of 67. All right, What I get is about 200. I should technically check to make sure I'm in degree mode, which I am. So we get that, and I'm sorry if there's any noise coming out of my computer just because it's doing a little bit of thinking itself right now. So b squared is equal to, not square root, b squared is equal to about 200.503. And then what I'll do is I'll take the square root. Now, don't do the answer. Do the rounded one. Stay consistent. And I get b is equal to 14.2, about, okay? Now, if you do want to just go to the point where maybe you get this answer right here. So maybe this was you. And then you just want to do second square root, second answer. And then report 14. See, you're going to get the same thing. You can see there's a very small difference. So the first decimal place is the fourth decimal place. And again, because we rounded to 3 decimal places in our intermediate work, that allowed us to kind of avoid the consequence in the end of plugging in only a few digits instead of the whole thing. But if you want to plug in the whole thing, that's totally fine. Again, as long as I can, it would be good if I could see some intermediate work for full credit, but I'm not going to nitpick you if we're off by a very, very small amount. So if we're off by like 1/100th of a unit, that's fine. Okay, so again, the law of cosines must be used because that's what the given information is. Okay, so then in that case, if we take a look at this one, all right, and remember, when in doubt, draw it out. So here's a 9. That makes this big F. Here's a 10. That makes this big G. And then this would become E. I guess I didn't specify that. You could really call it whatever you wanted. And then big G is 70. And big F, we'll call it theta because we don't know it. Now, if you think about it, if I was going to calculate it using the law of cosines, well, that's a problem, right? Because if I want to know big F, this is how you'd figure it out. So ordinarily, you'd have to do F squared equals E squared. And remember, not E the constant, E the variable. So E is not the greatest use in this case because if you type in E squared, believe it or not, your calculator will actually give a value to that number. E, G, cos F. So here's how I'd set it up. But here's the problem. You don't know little g. Right? You don't know little g. That wasn't given to us. Actually, no, you do know little g. I'm sorry. You don't know. Let's back that out. You don't know little e. Right? That's not given to us. We don't know that. So the law of cosines does not work. It's the law of sines that we want because what I know is that sine 70 over 10 equals sine f over 9, okay? And so one of the big takeaways is, right, when you have two variables in an equation, you're not going to get, or rather two unknowns in an equation, you're not going to get necessarily a single unique solution. So what we need to do is set up an equation where there's only one unknown, and see, you can see in this case, there's only one unknown, whereas in this case, you don't know E and you don't know F. So that's going to be challenging. Okay, and so now I solve it out. So I get 9 sine 70 equals 10 sine f. Okay, so that means that if I divide, I get 9 sine 70 over 10. And that's equal to the sine of f. So f equals the inverse sine of 9 sine 70 over 10. So inverse cosine 9 sine 70 over 10. Great. So what I get is f is approximately equal to 57.7 degrees. And that actually does make sense. And the reason that makes sense is because, okay, if 9 is smaller than 10, then the angle across from 9 should be smaller than the angle across from 10, because an angle measures the openness of these two sides, right? This is what we call the included angle. It measures how open these two sides, right? That's the definition of an angle, right? The space between like two rays or two segments, or I guess two lines. So if this angle is less open, this side is going to be shorter, because this side essentially tells you, or is related to, how far apart this point and this point are. The farther apart the points, the longer the side is going to be, the bigger the angle is going to be. Okay, so hopefully you found this to be helpful, and I really do hope you got it both right. Again, the moral of this do now was you need to be able to look at information, and you need to be able to figure out, do I use SOHCAHTOA, law of sines, or law of cosines? Okay, and thinking about under what scenarios you use each one. All right, best of luck today with wrapping up with the stuff we're doing. I'm excited to see how people do on the little test, and I'm really excited to see everyone at the hangout tomorrow. But keep it up. Don't forget to love math, and remember, you can do it. All right, thanks much. Looking forward to seeing everyone tomorrow, and have a wonderful day.